We're going to look at the next of our conic sections, which is called the circle. You're familiar with circles, and I've mentioned conic sections before, but we're going to go into more detail about what it means for it to be a conic section. And what a conic section simply is if we take an infinite cone being intersected by a plane, we get one of four shapes. If we take the cone and we intersect it perpendicular to its axis, then we get this perfect circle shape intersection. If we slant that plane just a little bit, and we can make it more and more eccentric, now we're stretching out the circle and we get an ellipse, which is a eccentric or stretched out circle. If we keep slicing until we are past this kind of bottom part, then we get our parabolic shape that we see here through the intersection. And if we keep rotating that plane until it intersects both ends of the cone, that's where we get our parabola or hyperbola shape, which is two parabolas on the same plane in opposite directions. And so those are our four conic sections. We've already covered the parabola, and next we're going to do the circle, followed by the ellipse. So to give our definition of a circle, it's the set of all points that line a fixed distance, called the radius, from a fixed point, called the center. And so, like with a parabola, the starting point, or kind of the anchor to a circle, instead of the vertex, we refer to as the center. And so here on this circle, we have a center at the origin 0, 0. And we have a fixed distance called the radius. And here we have a radius of 4. We can see we can go right 4 units, left 4 units, up or down 4 units, and any other diagonal distance will also be 4 units from the center. Now we can calculate that distance by using our distance formula, which is just an adjustment off of our Pythagorean theorem. As a review, let's look at finding distance. If I want to find the distance from the center to any given point on my circle, say this point here, well, I can draw a triangle by looking at the x-coordinate and the y-coordinate. And in order to find this distance, we can use our Pythagorean theorem. So we have our starting and ending points. And what we can do is say that I have my first point, x1, y1, which is just the coordinate 0, 0. And then I have my ending point, which is x2, y2, which is some unknown value that I don't have yet. And if I want to find the distance to this point using the Pythagorean theorem, what I first do is I say, okay, well, what's the length of this leg here? Well, to find the distance from one to the next, I'm looking at the distance between the point x0 and the point 2 on the x-axis. And so I take my second x value and I subtract my first x value. And then I get this distance on my horizontal axis. Then, to find the vertical distance, here to here, I take the y value of this point up here, and I subtract the y value from down here, which is just 0. So I take y2 and I subtract y1, and then I get the distance on this leg. And when I have those two values, what we can do then is we can square them and add them, and that gives us the square of the distance using our Pythagorean theorem. This is leg A and B and C. A squared plus B squared equals C squared. So if A is x2 minus x1 squared, and B is y2 minus y1 squared, and D is our distance squared, if I want to solve for the distance, then I just square root both sides, and then I'm left with this formula that we have here for distance. So we can use this to find the equation of a circle. If we want to find the equation of a circle with a radius 4 and the center at 0, 0, what we do is we use 0, 0 as the x1 and y1 coordinate, whatever our center is, and our distance is known as 4. And then we can find an equation that models all of the points that satisfy that condition, where x and y is any point on the circle. So we take our distance formula, x2 minus x1 squared, plus y2 minus y1 squared equals distance. Now x2 and y2 are going to be those points on our circle of any given point. So it kind of represents all the points on our circle. Then our center is going to be the points x1 and y1. Well, our center is 0, 0. So x1 and y1 are both 0. So x minus 0, y minus 0. And then lastly, we have our radius. Our radius is the distance to all those points from the center. And then we have the square root of that. So again, in order to get rid of the square root, well, we square both sides to kind of clean it up. And that helps get rid of that ugly radical in our equation. And if I have x minus 0 squared, that's just the same as x squared plus y squared equals 16. And this is the standard form of the equation for a circle that has a radius of 0, or 4, and its center located at 0, 0. Well, what if we move off of center, and center is now not the origin anymore? Well, we still follow the same pattern. So again, we can start with our distance formula. Square root. And so again, our x2 and y2, that just represents every single point on our circle. So we have x minus something squared, y minus something squared, all in the radical. And then our distance is our radius. So here, x1 and y1, that's our center, x1 and y1. So we plug in 3 and negative 2, and then our distance is a radius of 4. We want to get rid of the radical on both sides of the equation. So we square both sides, leaving us with x minus 3 squared plus y. The double negative makes it plus 2 squared equals 16. And now we have the standard form of a circle that has a center at 3, negative 2 and a radius of 4. So this leads us into the standard form. But before we do that, let's just look at a quick sketch and how we can represent that. So we have 3, negative 2 as our center. And if we have a radius of 4, that means in every single direction, we can go 4 units. And so I like to go in the cardinal directions of up, down, left, and right. And then we can kind of just draw a little circle around here to represent our circle. And that's pretty close. We can make it a little bit bigger. There we go. And there's our circle. So we'll see some similarities with the standard form of a circle as we do with the standard form of the parabola. Notice how we have these values of h and k again. On our parabola, they represented the vertex. On a circle, they represent the center. Just like with our parabola, notice how there is a sign switch with our h and k value. Inside that parentheses, we've got the sign switch. If we look and see we have our center at 3, negative 2, when we plugged it into our equation, we got the sign switch inside the parentheses, just like we would on the parabola. It's now happening just to both coordinates because they're both inside the binomial squared. Also notice that we have our radius squared as part of our formula. So the constant is the square of the radius. So using our formula, we can write equations and do various things as long as we know the center and the radius of our circle. So we want to find the equation of a circle with these given features using our formula. So if we have x minus h squared plus y minus k squared equals r squared, well, what we need to do is find the values of h, k, and r. Well, our center is given, so our values of h and k are 2 and negative 1. So we can substitute those into our equation. X minus 2 squared, y minus negative 1 squared. Now radius isn't given, but the diameter is. And recall that the diameter of a circle is equal to 2 times the radius. So if we're given the diameter of 6, then the radius has to be 3 units long. So we can now substitute that into our equation. We clean up any double negatives and simplify the radius expression, and we get the standard form of our equation with a center at 2, -1, and a radius of 3. Now we want to find another equation of a circle. Here we're given the center again, but now we're given a point on the circle. We're not given the radius. But that's okay, because if we know a point on the circle, our distance formula can be used to find the radius. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, where distance is our radius, and then x2 and y2 is one of our points. We'll just say it's the point on the circle. 3 minus and 4 minus. And then our other point is going to be our circle. -1 and 4, the center. So we take 3 minus -1 and we get 4 squared. 4 minus 4 is 0 squared. So our radius is the square root of 16, which equals 4. So we have our center at -1 and our k value of 4, and then our radius of 4. So we can plug it into our equation. X minus h squared, y minus k squared equals r squared. X plus 1, y minus 4, and then 16 for the radius squared. I'm actually going to add in another question on the fly here real quick. And so let's consider another problem. Let's say we want to find the equation of a circle, but instead we are given the endpoints of a diameter being the points 2, 6 and -6, 0. So we have a circle and we have some endpoints of a diameter. So it's going through the center of the circle somewhere, and we have these two endpoints. One of them is -6, 0, and the other is 2, 6. And so we need to figure out how to find the center and the radius. Well, first thing to consider is that the center is going to be the midpoint of any diameter going through the circle. And so we can use our midpoint formula in order to find where our center is located. Recall that our midpoint formula is the sum of the x's, x1 plus x2 divided by 2, and the sum of the y's divided by 2. So we take our x values, 2 plus -6 divided by 2, our y values, 6 plus 0 divided by 2. Simplify. We get a center located at -2, 3. There's our values for h and k. Now we need to find our radius. Well, the radius is going to be the distance from the center that we just found to either of those endpoints, and we can use either one. Equals the square root x2 minus x1 squared plus y2 minus y1 squared. So we'll use our center. Let's say our center at -2 and 3. And we'll go ahead and subtract one of the other points. So let's pick the point -6, 0. -6 minus, and so it's all getting the square root. And so for our distance, we'll go ahead and we'll get 4 squared plus 3 squared plus 9, 25. So our distance is 5, which is our value for our radius. So we can plug it into our equation. X minus h squared plus y minus k squared equals our radius squared. And there's the equation for our circle that has the points 2, 6 and -6, 0 as its diameter endpoints. Now let's go ahead and find the features of the graph if we're given the equation. We want to find the center and the radius. Well, if the equation is written in standard form, it's really easy. We identify h, k, and r. But if we're in general form, like these equations here, then we have to rewrite the equation into standard form. And just like with our parabolas, the way we rewrite equation from general form to standard form is by completing the square. The only difference here is that we have two variables being squared, so we need to complete the square twice. We're going to start by grouping the like variables and putting in the square for our process of completing the square. And like before, anything that we're not completing the square on gets moved to the other side of the equation, and then we need to put in our squares again for our completing the square on the right side to keep our equation balanced. So anything that goes on the left also goes in on the right. Then what we do is complete the square separately on each part. X squared plus 6x, we add 9 to get our perfect square trinomial, so it factors to be x plus 3 squared. Since we added 9 on the left, we have to add 9 on the right. Then we look at y squared minus 4y. If we add 4, we complete the square so that it factors to be y minus 2 squared. And then we add the right side of the equation, we get 64. Now that we're in standard form, we can compare it to the formula for standard form to identify h, k, and r. Well, since 3 is equal to negative h, that means h is negative 3. Since negative 2 is equal to negative k, k is equal to 2. Since 64 is equal to r squared, r equals 8. So our center is located at negative 3, 2, and our radius is 8. To complete the square again, we'll follow the same steps. I encourage you to pause and try it on your own first. This one is pretty easy. We group the like variables, and since there's no constant, we just have 0 plus the two things we'll be adding when we complete the square. We'll complete the square on x, giving us 16, x minus 4 squared. Complete the square on y, giving us 9, y plus 3 squared. We're going to add 16 and 9 to 0, giving us 25. Looking at our equation, h is 4, k is negative 3, notice the sign switch, and r is 5. So our center is located at 4, negative 3, with a radius of 5. Go ahead and try the next one on your own as well. Pause it and check your work. We'll group our like variables. Since the 15 is not part of the completing the square as a constant, we add it to the other side. And then we have two boxes being added as well. Complete the square on x, we're adding 1. Complete the square on y, we're adding 9. We factor these, x plus 1 squared, y plus 3 squared equals 25. H is negative 1, k is negative 3, r is 5, giving us a center at negative 1, negative 3, and a radius of 5.